This video is for class 9 physics, and in this video we are solving the numerical problems from exercise 3E. In the previous video we had completed till number 6, 7 and 8 was your homework, and we shall do number 9 onwards from here. A ball is released from a height and it reaches the ground in 3 seconds. So here you can see a ball is released from the height, from a height, and it reaches the ground in 3 seconds. If g equals to 9.8 meter per second square, so here two things are given to us: time and acceleration due to gravity. Now with the help of these two things we are supposed to calculate the height from which the ball was released. The height from which the ball was released. The velocity with which the ball will strike the ground. I'm supposed to find the velocity with which it will strike the ground. Let us try to understand the question number 9. We're trying to solve number 9. And I'm explaining question number 9. See, you can see here a ball is kept at a height h from the ground. Right? In question number 9, we are supposed to find the value of this h. Right? Here what you can see here is the initial velocity of the ball is 0. The initial velocity of the ball is 0 because the ball is at rest. So now what you can see here, when the ball falls down, of course it will have some velocity. Let that velocity be v, which I need to calculate in question number 9b. So here the few things are given, right? Initial velocity is given here. Initial velocity is given, u equals to 0, which I supposed to understand because the ball is at rest. Now other thing which is mentioned in the question, this ball will take 3 seconds to come down, right? And acceleration due to gravity given to us is 9.8 meter per second square, right? These two things are given to us, right? This and this, and with the help of this I'm supposed to find height and velocity, but indirectly they have given us initial velocity because the ball was at rest. Now let us try to see what happens when the ball strikes the ground. See, when the ball reaches the ground here, it will have certain velocity. That velocity I need to calculate, right? So let us go to its solution. I hope you understood the question. So coming to the solution of number 9, the things given to us: time is 3 seconds and acceleration due to gravity is 9.8 meter per second square, where initial velocity u is 0. Now to calculate the height h, I'm supposed to use this formula. This is the second equation of motion, which is s equals to ut plus half at square. So then replacing the values, s becomes h, u becomes 0, t becomes 3, half comes here, plus comes here, a becomes 9.8 meter per second square, whereas t square becomes 3 second into 3 second. Now you can ask me a question: why only this formula here? Why not v equals to u plus at, because the final velocity is not given? That's why. Why not v square equals to u square plus 2s? Again, the final velocity is not given, right? So these are the few things which is not given, so you need to take care of, right? So I have to use this formula, s equals to ut plus half at square. Now doing the calculation, see calculation part, 0 into 3, let me do it again once. 0 into 3 will give me 0, then 2 and 9.8 can be cancelled, we shall get 4.9 multiplied by 3 into 3. So second and second here gets cancelled by this second square, so ultimately I am getting 44.1 after the multiplication of 4.9 and 3 and 3. So this is my answer for the height of the stool, whatever I was using out there, right? So now Going to the next part, that is number V, velocity. To calculate velocity now I can use u plus at, right? U is 0 plus a is 9.8 meter per second square multiplied by 3 seconds, and finally I shall get 29.4 meter per second. I hope you understood this number 9. Now we can go to the next question, which is number 10. In question number 10, the things which are given to you is quite simple, and I think you can do it by yourself. So please try to do number 10 by yourself. Coming to the next question, question number 11. Let us go through the question. A ball is thrown vertically upwards. A ball is thrown vertically upwards. It goes to a height 20 meter, right? It goes to a height 20 meter and then again comes back to the ground. So here there are two motions, one going up and other coming down. Two motions, please remember. Taking acceleration due to gravity g to be 10 meter per second square, find the initial velocity of the ball. That means with the help of these two things here given to us, 20 meter and 10 meter, right? There are no hidden things given in the question right now, okay? The initial velocity of the ball, the final velocity of the ball on reaching the ground. So I am supposed to find the velocity with which the ball is thrown up, that is initial velocity of the ball. And in the second condition, when the ball is coming down, I am supposed to find its final velocity, right, on striking the ground or on reaching the ground. So total time of the journey of the ball also, that means whatever time is taken here and whatever time is taken here, I need to add them. I shall get a total time. Or if I have a formula of total time, I shall use the formula of total time. If you know the formula of total time, okay, T dash equals to 2u upon g. You can use that, okay. Now there's a small clip, okay, which will try to explain question number 11. So in this clip what happens is the ball is thrown up, right? So we can understand this as the ground level, the hand as the ground level, right? This hand as the ground level, and when the ball is thrown up, right, when the ball is thrown up, it reaches a height, okay, which is given in our question is supposed to be 20 meter. Supposed to be 20 meter. When the ball goes up, it's supposed to be 20 meter, right? So let us watch the clip and try to understand. Okay, under this condition what happened was the ball just returned, right? Okay, so we can assume the final velocity here is supposed to be 0. The final velocity here is supposed to be 0 because the ball stopped, that's why it is coming down. As we all know, the force of gravity is acting downwards, right? But the motion was upwards. This was the motion. Motion is upward, right? Whereas the force of gravity is acting downward. Gravity is acting downwards. So here you can see, so this particular question can be divided into two parts. One is the upward motion, the next one will be the downward motion. So for the upward motion, my final velocity given to me, is 0 because the ball stops and then comes back, right? The initial velocity I am supposed to calculate, whose value I don't know, right? And height given to us is 20 meter, whereas acceleration due to gravity should be minus 10 meter per second square. Now you can argue with me why this minus sign comes here, because this minus sign is for the upward motion. When the body is thrown up, gravity is acting downward. Therefore, there shall not be any acceleration, rather there will be retardation. I hope you understood this upward motion part. Now we can understand the downward motion part. Okay, when the ball came down, right, what should be my acceleration? It should be positive 10 meter per second square, right? Now because the force was also acting downwards, gravity is acting downwards, gravity is acting downwards. So in this case it is taken positive here. I hope you understood till here. Now under this condition, this is the second condition, I am supposed to find the final velocity. of the ball, right, when it strikes the ground, if this is the ground level here. So what will be the initial velocity in this case? What was the velocity up here? Up here, if you remember, the velocity was 0 when it started to fall down. The velocity was 0. How much distance did it travel? H equals to again the same value, which is 20 meter, right? So question number A is explained. This is the explanation for question number B. Now to explain question number C, that is 11C, I'm supposed to find the total time of the journey, right, while going up and then coming down. I hope you understood the question. Now let us try to go to its solution. Coming to the solution of number 11, we can see here two things are given to us. One is height, the other is acceleration due to gravity, which is 10 meter per second square. While going up, okay, the final velocity is 0. I hope you understood how. Now with the help of all these three values, 1, 2, 3, I'm supposed to calculate initial velocity. Can I use v equals to u plus at? No, because time is not given to us. Therefore I'm supposed to use v square equals to u square plus 2as. I cannot use s equals to ut plus half at square also, because it also has t in the equation. Therefore using this equation and then replacing the values here, v becomes, this v becomes 0, v square is 0 square, u square remains here, 2 comes here, multiplied by a. Now a becomes minus 10. I hope you understood why minus 10, because the ball was going up, multiplied by 20. This is the distance traveled by the ball. Therefore 0 into 0 will give me 0, u square comes here, plus into minus, I think it's getting complicated again, so plus into plus into minus will give me minus, 2 into 20 is giving me 400. So again taking u on the other side, it becomes minus u square with minus 400, minus and minus gets cancelled, right? Now I can write u square equals to 400 now. So u will be equal to under root 400. I hope you understood how. The square root of 400 is 20. Hence the value of u as the initial velocity is 20 meter per second. I hope you understood number 1 while the motion is going up. Now we can go to the next part, which is number 11b. In question number 11b, while coming down, my initial velocity is 0, right, because the upward motion's final velocity becomes the initial velocity of the downward motion. So using the formula v square equals to u square plus 2as, I am supposed to calculate this final velocity. So v square equals to u square plus 2as, right? I will just replace the values. U square becomes 0 square, 2as becomes 2 into 10 into 20. This time remember it is taken plus. Why? There is no minus sign, because the motion is downward. Remember that. So v square equals to 0 square means 0 plus 2 into 20 into 10 shall give me again 400. So v square equals to 400. and v equals to under root 400, therefore the value of v comes 20 meter per second. Okay, this is the same calculation as before, that's why I'm going a little bit faster. So now listen, what was the velocity with which it was thrown? It was 20 meter per second. What is the velocity when it is coming down? It is 20 meter per second. So here the initial velocity and the final velocity remains same, right? Okay, this reminds me of the law of conservation of energy also. Now how it is related, we shall discuss it afterwards. Now I hope this number B is also clear. We can go to number C now. Coming to the solution of number C, which is total time. To calculate the total time, I have used the formula T dash equals to 2u upon g. I have discussed it before playing the video. So T dash equals to 2 into 20 upon 10, because the initial velocity was 20. So T dash equals to 4 seconds, right? This is the shorter way to do it. Otherwise you can use equations of motion also, then you can find it v equals to u plus at in both the cases, and then add those t's, you shall get the answer. But I think this is much more easier. So this was all about number 11, right? Thank you so much.